Hey guys, it's Miss Wallace again, and this is the kind of video where you get really mad at me because we have spent the last 2 weeks learning some techniques for solving quadratic equations, and here's where I tell you, yeah, there was actually a quicker way of doing it. Sorry, y'all. I still love you. So there's not really a lot to write down this week. We're going to be spending a lot of time in Desmos, so I'm going to cut the video here in a minute and do some work on Desmos, but the title of this week's lesson is Solving Quadratic Equations Using Graphing. Now, of course, solving this algebraically is still valuable. And so if you'll think back over the last couple weeks, first of all, we learned a technique called factoring. And so this was the first week of new material. And then the second week of new material, we actually learned the quadratic formula. And so I just want to quickly review those just so I can prove to you and I can show you how the graphing the solutions actually works using Desmos. So by factoring, I'm just going to give us like a super simple example, a very tiny little baby quadratic that's real easy to factor. So we have worked with quadratic equations the past couple weeks, so I'm going to do this twice. Just to show you that you get the same answer both times. So the first week, we did factoring, and so we would have just factored this. It's already equal to 0, so I would have, and there's no coefficient out here in the front, there's no a value, so I don't have to use the box method. So I simply go to the add and multiply method. So I look for two things that will add together to get 4, multiply together to get 3, and that ends up being 3 times 1 and 3 plus 1. And so my factors here are 3 and 1. I slap those into two sets of parentheses, and so if I factored this quadratic, x plus 3 and x plus 1 end up being my factors, I would have set those equal to 0. So take the first one equal to 0, second one equal to 0, and then solve. And so by subtracting 3 on each side, we got that the solution was x is either equal to negative 3, or if I subtract 1 on each side, that x would be equal to negative 1. So either of those solutions. And that's how we solved these the first week. Then last week we looked at problems that were not necessarily factorable like this. We used the quadratic formula. Now we already know that this will factor, but I just want to show you that the quadratic formula would have worked with this as well. So remember, the quadratic formula is, if you listen to the Pop Goes the Weasel song, it's x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And I know if we were in class, you would have been groaning. That's fine. I miss you all. So you can groan at your house. So x is equal to, I've got my a value, which is 1, my b value, which is 4, c value, which is 3. And so I'm just going to plug that in, negative 4 plus or minus the square root of 4 squared minus 4 times 1 times 3 from my a and my c, all over 2 times a, which a is 1. And so then I'm just going to work that and simplify it, and so I get negative 4 plus or minus, on the inside of the square root, 4 squared is 16, minus, I'm going to do negative 4 times 1, which is negative 4, times 3 again, which is negative 12. Multiplying those last three numbers together, all over 2, because 2 times 1 is 2 on the bottom. And then I just have to simplify my square root, so x is equal to negative 4 plus or minus the square root of 16 minus 12 is 4, all over 2, and we always check and see, is this actually a perfect square, or is it prime, or does it need to be simplified? And good news for us is that 4 is actually a perfect square number, so we end up with negative 4 plus or minus the number 2, square root of 4 is 2, all over 2. And then I write my answers once with the plus, once with the minus, so the first answer is going to be negative 4 plus 2 over 2, or the second answer is going to be negative 4 minus 2 over 2. And if all works out, we should get these same answers because we've already done it by factoring. So negative 4 plus 2 is negative 2 over 2. Well, look, there's our negative 1. Or this is going to be negative 6 over 2, which is negative 3. Well, look, we got the same answer with factoring as we did with the quadratic formula. And so, again, this is just a review of what we've done the past 2 weeks. Now what I want to show you is how would we find this answer on Desmos, or how would we find it by using a graph? And so I'm going to flip the video over to Desmos and I'm going to show you. Just remember that the answers were negative 3, negative 1. Alright, so here we are on Desmos, and if you remember, the equation that we were working with was the equation x squared plus, x squared plus 4x plus 3 is equal to 0. And so if you type that into Desmos, notice that there's 2 lines that appear, and we can click on both of those lines and find where they cross the x-axis. And if we find where they cross the x-axis, they actually cross at negative 3 and negative 1. And, well, golly gee, that was the same answer we got when we did this problem by using factoring and by using the quadratic formula. So yes, you could have been typing these equations into Desmos this whole time. Now, just typing a question in and finding a button on the computer and clicking it and finding the numbers doesn't really help you know why this works. And so I know it sounds cliche, but that's why we had to do this last, is because we have to know why it works. So let's look at a couple more examples of how you can do this. And actually, I am going to make the case for, instead of typing in 0, because we always have these equations equal to 0, 0 is an output value. I'm actually going to change the 0 to y, and I'll explain this a little more as we go through some of these examples, but if we type in the equation with a y instead of equal to 0, notice we get this really nice parabola instead of just these 2 solid lines. If we get the parabola, and if you remember, a parabola is just a U-shaped graph. We've seen these before. Notice it still crosses at negative 3, negative 1. And so it still gives us our solutions. So x is equal to negative 3 and x is equal to negative 1. So let's look at another example of something that you might see in your quizzes practice. So I'm going to type in the equation 3x squared minus 4x minus 4. And so we're going to get an equation, or a graph that looks something like this. Notice you don't even have to type in the equals 0 part. You can. You really don't even have to type in the equals y part. But notice that the 0 gives you these, if you type in equal to 0, it gives you these straight up and down lines. If you don't type in equal to 0, or if you type in equal to y, it gives you this nice parabola. And so I'm going to go with the parabola. I'm just going to leave it where it's not even equal to 0. So when I type that in, notice I get the answers negative 0.667. And notice my y value is 0. We're only looking for the x value in these. So my 2 solutions are going to be negative 0.667, which also is about negative 2/3, and also the number 2. And so that would be my answer. Those would be the answers that I would select for my x values. And so again, we're just looking for where do they cross the x-axis, and we click on those points. So notice and think back to the examples that we did last week, that so far we've gotten 2 answers, right? We've gotten 2 solutions. We know that quadratics have 2 answers, and so far so good. Let's look at an example that looks like this. X squared minus 8x plus 16. And again, you could type in equal to 0. You could just leave it like it is, or equal to y. If you type in equal to 0, of course, it gives you the line. And notice that the line is just at 4. So if I backspace that off and I just put in the equation, or I put in equal to y, notice we got the parabola. And where does it touch the x-axis? Well, it only touches the x-axis in one place. It's almost like the parabola is sitting on top of the x-axis. So there are cases where you are only going to have one solution. If your parabola, if this shape only, this U-shaped graph only touches the x-axis one time, your answer is just going to be 4 in this case. The x value is your answer, and so there's only one if it only touches the x-axis once. Let's look at one more example. So we're going to type in, let's say we're given the problem x squared. Again, I'm just typing in the problem that I see off of the quizzes or off of the worksheet. So plus 2. And I can leave it there. That gives me the equation. If you type in equal to y, it gives you the same parabola. If I type in equals 0, notice what happens. Now, I can zoom in and out as far as I want to, but do you see a line? No, there's nothing there. And so notice what happens if I back that off again, or if I put in the equal to y. Look at what my parabola is doing. So my graph is going down toward the x-axis, but it never actually gets there. Now we do have some points here, but neither of those points actually touch the x-axis. If you have a graph that does not touch the x-axis, there are no solutions. Now that'll be an answer choice. It may be written out like that. That will be what you click on though. If you have a parabola that does not have any place where the line is touching the x-axis. So I'm going to flip back to the notebook and we're going to sort of summarize what we just have discovered. So in summary, and if you want to write this down at the bottom of the notes we took earlier, we've now looked at 3 different cases for different types of solutions that we might get, all of which we can solve just by looking at the graph. So if you think back to our first example we typed in, it was the x squared plus 4x plus 3 is equal to 0. That was our original problem. And we found that the graph looked something like this. We had answers at both -3, and we had an answer or a solution at -1. And so the graph looked something like this, and our parabola went through those 2 points, and so we were able to tell that those were 2 solutions. So that would be an example of a solution where you have 2 answers or 2 solutions. And then we also looked at the example where we had the graph of x squared minus 8x plus 6 is equal to 0. And remember, that's the one that landed on 1, 2, 3, 4, and it only touched the x-axis once. And so our parabola looked something like this, and that would be an example of only one solution. And the final case was the x squared minus 2x plus 2 is equal to 0, and that graph looked like this. And so our graph looks something like this, and we noticed that it didn't touch the x-axis at all, and so remember we called that no solution. So as you are working through these problems and typing them into Desmos in order to find the graph and find the solution, you are going to have several cases. So you could have the 2 solution, and so when you type that in and you see where it crosses the x-axis, your answers are going to be written as follows. So when the answer was -3 and -1, we're just going to write x is equal to -3, x is equal to -1. For one solution, it's just going to be one number. So for this one, x was equal to 4. So we're just going to write x is equal to 4 as our final answer. And for no solution, of course, the answer is just going to be, you're going to click no solution. And that is how you solve quadratic equations by using graphs.